Okay, Oak Rovers, this is a video that's going to help you model adding integers. And the first adding integer problem I'm going to have is -3 plus -5. Okay, and we're going to use the chip model or the algebra tile model. And I have an algebra tile here I'm going to put up there, and that algebra tile is a unit tile. And I flip it over, if you notice it has two colored sides. I have one side that is blue and one side that is red. The blue side I'm going to call a positive 1. So the blue side is going to be a positive 1. The red side is going to be -1. So what I'm going to do is I'm going to build the equation -3 plus -5. Well, -3 is just going to look like 3 red tiles. And then if I add -5 to that, I'll have 5 red tiles. This is modeling the equation -3 plus -5. And I'm going to combine them together into one big thing. Now to draw that using my algebra tiles, I have an open tile or an open square is -1 and the closed squares are +1. So the way I'm going to draw that is just like this. I'm going to have 3 -1s plus 5 -1s, and I don't have any zeros I can take off. So when I combine that, what that's going to be equal to is just -8, because when I add them together, I just make one big pile of -8. So that's how I model -3 plus -5 to get to -8. Now I'm going to try something a little bit different. I'm going to try -7. I'll just bring these down here. And here's -7 right there. So I'm going to write that down in my model as 7 open squares. There's my open squares, plus 4. So this is -7 plus 4. I have 7 negatives and 4 positives. And I'm going to draw those with closed circles on my model. Now here's what happens when there are different terms. What I can do, or when there are different signs, I can take a positive and a negative, and one positive and one negative makes 0. So this right there is a 0. And what I can do when I have a 0 is I can just remove it right from the table. So I can move that right off the table. But I have 3 more sets of zeros that I can take off also. So there's my second set of 0. There's my third set of 0. And there's my fourth set of 0. And I'm left with 3 red ones. So I'm going to be left with -3 because each of these are -1. Now to show that on my drawing, I'm just going to circle my 0 pairs. And I have 4 0 pairs, and each one of those 0 pairs can be dragged right off or taken right off my algebra tile mat. And I'm going to be left with just 3 -1 units. So that would be modeling -7 plus 4, and that's equal to -3. I have 2 more that I'm going to do for you. The next one is going to be 3 plus -5. So I'm going to just leave them, since they're already like that. I'm going to just keep them like this. There's my -5. And there's my 3. So there's 3 plus -5. And I'm going to combine those and see what I have left over after I do that. And I remove my 0 pairs. So to draw that on my algebra mat, I have 3 positives, which are filled in circles or squares. And I have 5 open squares, which are -1s. So when I combine them, I'm going to remove my 0 pairs, and I'm going to match them up. And I have these 3 positive ones and those 3 negative ones. They're going to make 0. So what I'm going to do is I'm going to combine all those this time. I'm going to do it in one big circle. And that makes 0 because +3 and -3 make 0. So I'll take all those 0 pairs off, and I'm going to be left with just -2. So 3 plus -5 is equal to -2. I have one last one to do, and that is going to be right down here, -3 plus 4. This is a little bit different. I'll show you why. There's my -3. And there's my 4. So to represent that on my algebra tile, I have 3 negatives and my 4 positives. And again, I'm going to remove my 0 pairs. And when I remove my zeros, I'll take my 3 positives and my 3 negatives, because 3 positives and 3 negatives, that's just going to make 0. So I'm just going to remove them right from the board, slide them up, and I'm going to be left with +1. So I have a +1 for that. And that's how I model my adding integers. Now, the problems that I have here, I'll just show you the different ones that I have. I'll show it right down over here. I have -3 plus -5 is equal to -8. I have -7 plus 4 is equal to -3. I have 3 plus -5 is equal to -2. And I have -3 plus 4 is equal to 1. Okay? And those are the 4 problems that I just did. From those problems, I'm going to make algebra rules. Okay? And there's going to be some addition rules. And from those 4 problems, I'm going to have 3 cases. And the first case is when I add a positive plus a positive. We've been adding positives plus a positive for a long time. An example of that is going to be 5 plus 4 is equal to 9. And you've been doing that probably since kindergarten, maybe even before. Another example is 3 plus 2 is equal to 5. Those are examples of a positive plus a positive. What I say when I add a positive plus a positive, I say that they work together because the signs are the same. When they work together, all I do is I add the numbers. And when it's a positive plus a positive, my answer is positive. Okay? Another case that we have where they work together is a negative plus a negative. And an example that we did above of a negative plus a negative was -3 plus -5 is equal to -8. Okay, again, like I just said, I would say that these work together also, because the signs are the same, so they work together. And what I do when they work together, what I'm doing with the 5 and the 3, is I'm just adding them up. So I add the numbers, and when they're both negative and I'm adding, my answer is negative. There's one more case that I'm going to talk about, and that's when I either add a positive plus a negative, or a negative plus a positive. Some examples that we have, and I have two of them right down here. I have 3 plus -5 is equal to -2, and -3 plus 4 is equal to 1. And do they work together or against each other? And when the signs are different, I say they work against each other. Okay? I say they work against each other. Now, I ask questions when they work against each other. First of all, I ask, who wins the battle? So who wins the battle? In this case, since the negative is bigger, the negative wins the battle. In this case, since the positive is bigger, the positive wins the battle. Now if I look when the negative wins the battle, my answer is negative. When the positive wins the battle, the answer is positive. So whoever wins the battle, that gives the sign. That gives the sign for the answer. Oopsie. That gives the sign for the answer. Whoever wins the battle, that's the sign for the answer. Now how did I get the 1? And how did I get the 1 and how did I get the 2? Well, what you notice is I'm just subtracting. 5 minus 3 is 2, 4 minus 3 is 1. So instead of adding like I did above in both of the cases where they work together, I subtract the two numbers. And that answer is going to be the number part of your answer. So that gives the number. Okay? So for instance, so when I look at these problems, I say who won the battle? Well, the negative one. So I know my answer is negative. So that's how I got the sign. The way I got the numbers, I just took 5 minus 3 is equal to 2. On this one, negative 3 plus 4, the positive won the battle because the positive is bigger. And then I take 4 minus 3 and I get 1. And that's how I got the number. So whoever wins the battle gives me the sign, and then I subtract to get the number that goes along with that sign. And that's how you're going to add integers, both as a model and also the process you use to add integers. I hope this helps. If you have any questions, make sure you stop into Mr. Pedersen's room, and I can help you with this too.